Okay, hey everybody. So, if you remember anything from the last video, yeah, this thing crashed really hard, like the computer restarted itself. So, I may not show you Desmos today. I'll just draw the graphs for you because I can draw them just fine. Um, but I'll attempt to include Desmos on here again in a second, okay? I want to make sure we can actually get through a video though, and then we'll do some Desmos work further in, okay? Let's do that because I don't know what just happened, but it did, and that was kind of crazy. Okay, so let's try that again. Um, um, Let me make sure we're good to go. As usual, I will start writing when the video has started. Let me make sure we're good here. Okay, excellent. All right, here we go. Just do a little writing here. Okay, all right, so we are good to go. Okay, here we go, guys. All right, so let's try that one more again. Without the crashing computer. Okay, so before we had talked about, we were attempting to look at some graphs, right? We were attempting to look at some linear graphs so you can see what those look like. And remember I told you that when you see this x and it's got a nice clean, no exponents, no it being on the bottom of a fraction, nothing like that, it's just a straight line, okay? All right, great. Let's have a look at another example of that and how to read answers off of it, because I think that's really where some of you may be kind of crisscross. You're kind of like, what in the world? How am I supposed to tell what's what on there? So let's take the graph of well, no, let's not work harder than we need to. Let's take this exact same graph, okay? Let's say, so this function right here, this is f of x equals 2x plus 3, okay? Here, let's clean this up a little bit. Here, let's make a copy. By the way, here's a quick study tip for some of you, because I have a very, very deep and a rich set of experience in learning. And so just, here's a learning technique, okay? Keeping your paper or keeping your screen clear does affect how you think. So that jumble up there, yeah, we could have kept working in there, but no, we need a fresh sheet of paper. I encourage you, if you feel stuck in math sometimes, stop working the problem on the same piece of paper. Change pieces of paper. And even if you need to, get a piece of plain white paper, even without lines. Try either of those. For some of you, a piece of paper with lines will help you because it just has structure that'll help ground you and help you work through it. But for some of you, even the lines will distract you. Get a plain piece of white copy paper, and you'd be surprised how much starting a problem over on a piece of empty paper can help clear your mind and help you move on, okay? Anyhow, so fine, let's take this exact same one. Let's say someone asks of you, what is f of negative 3 here? What is f of negative 3? Do not work it out. Instead, let's look at our graph and see what f of negative 3 is. So remember, when somebody asks f of something, what's normally in that number's place is x, okay? And you're asking what the y is going to be for that. So what you do is you take that number that you see here, which is the x, because remember, normally it looks like this, right? Normally it looks like this. Where'd the x go? It got changed out for negative 3. So let's go to negative 3 on the graph. That's right here. Now some of you are going to say, wait, Mike, negative 3 is down here. But that's on the y-axis, baby. Remember, we're looking at the x-axis. So go to negative 3 on the x-axis, and now look at where the graph is at negative 3 for x. So let's take that piece by piece. Negative 3 is right here on the x. Let's go down until we hit the graph at y. Boom. This is where the graph touches at y for negative 3 at x. Where is that on the y-axis? Negative 3. The answer to this is negative 3. And you can tell because you followed the instructions. You went to -3 on the x, and then you went down from there until you touched the graph. It just happened to be that the graph was lined up with -3 on the y-axis. This is what you're looking for. F of -3 is -3. Now let's put that in this equation and see if it's true. Because we just told that from reading a graph. Let's put it in the equation to see if it's true. F of -3 should be equal to 2 times -3 plus 3. 2 times -3 is -6. And -6 plus 3 is indeed -3. So see how it doesn't really matter how you get there. You're going to get to the same place no matter what you do. As long as your technique is clean, you'll get to the right answers. Let's take another one though, because I don't like that that one coincidentally gave you the same thing. For some of you that may be a little jarring. I'm going to use this exact same problem to make another point. Let's try this for 2. F of 2 is what? Do not work it out over here. Instead, let's look at the graph. Remember, when we say f of 2, we're saying 2 is x. So let's go to 2 on the x-axis, which is right here. And then let's go up on the y-axis until we bump into the line. Okay? So here, let me get this highlighter here. Boop. This is where it bumps into that graph. Now, some of you are going to look like and be like, wait, Mike, doesn't it hit here? Go in a straight line. When you're reading answers from a graph without working it out mathematically, you have to go in a perfectly straight line. Don't take anything that is not directly above that point. Okay, so we went in a perfectly straight line. This point right here lines up with this part of the x-axis. Or sorry, of the y-axis. Okay, so whatever this is our answer. So this is the 2 part of our coordinate because we went 2 on the x-axis. What is this on the y? Let's count it. 1, 2. I need to use a highlighter for those so you see that we're not on this axis. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so this right here is at 7. 7 on the y-axis. So the answer to this should be 2, 7 because we went to 2 and then we went straight up until we hit this, and we hit that at 7. Now let's put it in the formula to see if that's true, because what this is saying is for this function, when x is 2, y is 7, and you can see that because a line touches at 7 when x is 2. Let's put it in the formula to see if that's true. So f of 2, and I'll put this directly underneath it too. F of 2 equals 2 times 2 plus 3. 2 times 2 is 4. 4 plus 3 is 7. 2f of 2 is equal to 7. And that's exactly what we see right here. Let me highlight it in a different color for you. This is how you read a graph by looking at it. Okay? All right? Let's try an example problem before we move on to x squared and some other exponential functions, okay? Because if you can learn how to read a simple graph, you can read any other graph. The technique, no matter what type of complicated graph you get, the technique for reading it is the exact same. So learn it with lines, and then we'll go to something more complex. We're going to master the simple before we go to the complex. Let's do f of x equals 1/2 x. Okay? So that means whatever points we do here, we're going to be cutting in half. All right? Now, remember I told you that to do something simple for graphing is to take one positive number, a 0, and a negative number. Remember we did that up here? We did a positive 1, we did a 0, and then we did -1 for x. So let's do the same thing here. Since I see that this is 1/2 x, I'm not interested in cutting 1 in half because that's going to give us a decimal. And there's really no need of working harder than we have to right now. So let's not do that. Let's use even numbers so we always end up with a regular number. So I'm going to do 2, 0, and negative 2 for this, because I know if we cut it in half, we'll end up with 1. So that's easier. So fine, let's do f of 2, and I'll work it down here, okay? F of 2 is equal to 1/2 times 2. And 1/2 of 2 is 1, okay? So the point for this first one should be 2, 1. Let's do f of 0. F of 0 is equal to 1/2 times 0. And half of 0 is 0, because if you ain't got nothing, you can take half of nothing and still get nothing, okay? So the point for 0 should be 0. And then f of negative 2 is our last point. 1/2 of negative 2 is negative 1. So f of negative 2 is negative 1. So let's put that down. All right, ta-da, we've got our points, okay? This is what we're going to graph. These right here is what's going on our graph. And this right here is how we solve to figure out what points were going on the graph, okay? Remember that, because that technique we'll be using to derive the points for our others. Okay, so our first point is at 2. Let's do that with the highlighter so we don't confuse things. And we're going to go up 1, okay? So we should be right here, okay? Because this is 1, 2, and that's 1 right there. Now I'm not going to put dashes on this. I want you to learn how to eyeball it with the graphing paper without needing the dashes. So just have a look. All I did was I started from the middle and I went over 1, 2, and then I went up 1. That's our first point. Our next point says to go to 0 and don't go up anymore. So congratulations, we're done for that point, okay? All right, and then our last point says to go to negative 2. All right, so I'm going to do that. And then it says to go a down 1. So let's do that. We're going to go down 1. And so our point should be right here. Let's connect those points. Okay, let's go ahead and label that real quick. All right, that's our line. Okay, now remember we've done this before and you kind of saw that this is going to be a straight line anyhow. Let's get some answers from this line without actually working the problem. So if I say to you, what is f of 5? Okay, what is f of 5? Now this should give us some decimal because half of 5 is not going to be an even number, but I'm going to show you the graph never lies to you. The graph will not lie to you. So let's go over here to 5. So let's go 1, 2, 3, 4, 5. And remember, you go straight up until it hits the graph. So let's go straight up. Right here. Notice how that doesn't hit on a clean part. It hits somewhere in the middle. Now this actually looks like it's a little bit over middle, so I didn't draw a perfect line. But the answer to 1/2 of 5 should be about 2.5, right? And look at that. This is about 2.5. The graph doesn't lie. Let's do something a little more clean. So let's do f of 6. Let's go over 1, 2, 3, 4, 5, 6. All right, so let's start here and go straight up. Okay, and you can see my graph isn't perfect. It actually lands a little bit above 3, right? Because here's 3. Okay, so it should be 3 here. But again, my graph isn't drawn perfectly. And take a look, you can see why it isn't. This part of the line is zigzag. So let's see what happens if we correct this. I think we can actually correct this because Notability is awesome. Let me see if I can grab it. Here, I'll just erase it and draw it perfectly this time. Oh, I still didn't do it right. It's pretty close. Well, anyhow, put it in your formula. Here you go. I was trying to show you that the graph doesn't lie. When you have graphs on a test, you don't have to worry about them being poorly drawn. Here, let's do this real quick. F of 6 equals 1/2 times 6, and 1/2 times 6, is 3. So you can see mathematically that when x is 6, it should be 3, okay? But that's how you read answers off of a graph. I was trying to show you a point here, but my line is not perfectly centered, and if it's not perfectly centered, it will look like it's slightly off at 3, but you can see how it should be about 3, and you can see how it should be about 2.5. Calculator will tell you that, okay? All right, so fine. Let's move on to some other examples because I don't want to spend too much on linear, as most of you are already comfortable with linear, so we don't need to spend a lot of time on it. But if you grasp the concepts here, and the concepts I wanted you to get was, A, when you put in x points, you just stick them here, and this thing will spit out your y points. You then take your y points and put those dots on a graph. Connect the dots. It's not always going to make a straight line, but it'll make a shape. When you need to get answers, look on your x-axis for whatever they're asking for. In this case, if they're asking for f of 5, you would look over here and then go straight up until you hit that graph. And wherever it hits the graph is your y answer. And that's usually what they're asking for when they ask for f of something. Okay? All right, so let's try that with something that's not linear so you can take this basic knowledge and apply it to something more complex. Take f of x is equal to x to the 4th. Okay? Let's take a look at that. First thing we're going to do is the same technique I've been showing you. Okay? I want you to take one, actually that won't work here, and I know it won't work here. Let's attempt to look at this on Desmos, because I was about to say, like, I know what x to the 4th looks like, and it's a straight up lie if I give you 3 points. This is one of those graphs where you have to plot more than 3 points to see what's going on. So let me pull up Desmos here for you. Cross your fingers and pray this works, y'all. Let's hope this doesn't self-destruct itself, because last time it did it exploded. All right, here we go. Okay, we're good to go. All right, so here we go. Let's go x. And by the way, when you need to put graphs on here, if you have to do an exponent, you're going to use key number 6 to make a exponent thingamabob. Or you can simply go here on the keyboard and use the A to the B button. So you go, literally just type x, okay? And then, or you can click it here, and then type in your A to B. And that'll ask you, the A is whatever your first letter is, and the B is whatever the number is. So we're going to put in x to the 4th, okay? Ta-da! This is the graph. Now if I zoom in, look at that, okay? Now, if someone asks you on this graph, what is f of -1, you would go here, and ta-da, when f is -1 for this, the answer is 1, okay? And you can see that if we flip back to working this out. And let me get the iPad pulled back up here. Because if we take, if we take -1 here and plug it in, okay, we get f of -1 equals -1 to the 4th. And -1 times -1 times -1 times -1, 1 times 1 is a 1. So it had to work out like that, okay? If you do the same thing for 0, get 0, do the same thing for 1. Okay, 1 times itself 4 times. Yeah, I'll ignore that 4 in there. My brain's going faster than my hand. Okay. All right. Bloop. Okay. If someone asked you, let's go back to Desmos because most of this worksheet is about putting in these functions on a calculator. I want you to be able to read that. If someone asked you what is f of 2, okay, you would look at 2, and then you got to go all the way. Oh my lord, you've got to take this 2, which you're right here, and you got to go in a straight line and look all the way up until that touches that graph at 2. It touches right here. Okay, f of 2 for this function is 16. And you know that's got to be true. Let's go back to the math and look and see why that's true. Okay, that's true in this case because f of 2 would be the same thing as 2 to the 4th. And 2 times 2 times 2 times 2. These two make 4. These two make 4. 4 times 4 is 16. F of 2 has to be 16. So if we were to graph this on paper, we'd have to go here and go all the way, like way on out here, something crazy. We're not doing all that, okay? That's why it asks you to use a graphing calculator, okay? Let's have a look at another one on the graphing calculator. Again, I want you comfortable putting this stuff in a graphing calculator because thankfully, and be glad you don't have to do this manually. Although, not really. I don't see you doing a whole lot of this manually in the first week of 8th grade. Like, come on. Now, you may be doing some of this manually later. That's fine. But, you know, it's okay if you're, you know. But anyway, okay, fine. So, let's use our button, okay? Remember, when we need to do some exponent, remember, we just use this a to the b button to take our x and make it a square. We're going to use the same a to b button if we were to take, say, the number 5 and raise it to the x, okay? Now, what this means when you see this 5 to the x is it means take 5 and multiply it times itself x times. Some of you are going, what do you mean x times? It means take 5 and multiply it against itself however many times you want. Do we want that x to be 5? Do we want that x to be 10? Do we want that x to be 1? Do we want it to be 2? Take 5 and multiply it times itself however many times you want. That's why we put a letter in its place. And it doesn't matter if that letter is X, or if that letter is A, or if that letter is D. It does not matter. But for calculator's sake, we're going to use X, okay? For the calculator, make sure you use X. But for calculation's sake, like actually working it out, it doesn't matter. All right, so let's look at this graph. Okay, what would you do if someone asked you, what is f of 2 for this? Okay, hopefully you got your graphing calculator out and you've put this in already. What is f of 2 here? Okay, here we go. F of 2, you start here at 2 on your x-axis and look all the way up until you see it touch at 2. And that's going to be right here. Don't be tempted to stop right here. It's not here. It's right here. 25. For 5 to the x power, f of 2 is 25. Because 5 to the 2 would be 25. Okay, let's work another one using this exact same one. For f of x, here, let me go ahead and put this in exactly as you may see it on your test or quiz or whatever you may be doing. F of x equals 5 to the x, okay? For f of x equals 5 to the x, what would be the value of f of negative 2? What is f of negative 2 for this function right here? Use your, oh, I'm so sorry, y'all, you can't see. Ah, there you go. Sorry, you didn't see any of that before now. Yikes, cringy. Okay, here, let's look at that again together. Sorry, heaven help me. All right, so fine. For f of here, can y'all see that? Hang on. Oh, I feel so bad. You didn't even see it that whole time. Okay, there you go. All right, hopefully you can see better now. So for f of negative 2 for this function, okay, I'll work this one with you, and then you can work the next one on your own because I didn't know you couldn't see it before. For f of negative 2, you would go to negative 2 here on the x-axis, okay, and then look straight up. This is what f of negative 2 is for this function, 0.04. Okay? So on your worksheets or on whatever you have, whether it be a test or whatever it may be, you're going to go over here to the side, type in your function. Let's work another one. Let's do 3 to the x power. Okay? You're going to type in your function, and it's going to very kindly graph the function for you. Okay? Then if they ask you something like, what is f to the 0? You're going to look on the x-axis for whatever the f is. So they said f of 0, so you look for 0 on the x-axis, which is right here, and then look where the graph touches 0, which is right here at 1. F of 0 is 1 for this graph. Okay? Now you try and work 2 of these. I want you to find f of 1, and don't look at the answers. God, calculator, please. All right, I'm going to type it in underneath this window. Yeah, because the bottom of my iPad's still showing here. Great. All right, I want you to find f of 1 for this. Wait, let me see if you can still see this. Find f of 1 for this, and find f of negative 1. All right? Find those two on this graph. Use your own graphing calculator, or you can look at my screen. I'd rather you be putting this in your own graphing calculator, as you're going to need to know how to use it on your test or whatever coursework you may be doing. You're likely going to need to know how to use a graphing calculator. Okay? Pause me now and try those. Okay? Hopefully you've already paused and worked through this. So for f of 1, you take your mouse and just follow it on up. It touches the graph at 3. So f of 1 for this should be 3. For the next one, you go to your negative 1, follow it until it hits the graph. For this one, you should have f of negative 1 is 0.33. Other way of listing that is 1/3. Okay? Either or would be okay if you worked it manually. All right? Okay? Let's have a look at a... well, before we move on, let me put this graphing calculator up, because I just realized your worksheet wants you to recognize some patterns here. When you run into these exponential functions, so anything that you raise to a power, so whether it be 10 to the x or 5 to the x, or, you know, I don't know, 5 to the... Well, no, I can't say that. I was getting ready to say that. You'll notice that your graph always makes this curve. It does something like this, or it'll do something like this. Okay? It doesn't seem to want to go below 0. So when you see a graph that looks like this, shoots up like that, does that thing, okay? These are called hyperbolic functions. Okay? It means they make this signature shape where it gets really small really fast, or it gets really big really fast. These are called hyperbolic functions. You don't have to know that name. Just know that if you see this signature shape, it is something, it is some number to the xth power. Okay? Let's have a look at another type of graph. All right, and y'all screenshot that if you need to too. It's going to be some number to the x when you see that signature shape. That signature shape can also look like this as well. But you'll know it. It doesn't want to go below 0, and it gets really big really fast and really small really fast. These are hyperbolic functions. and they always feature some number to the x. Some examples of that would be like 5 to the x, 2 to the x, 10 to the x, whatever. Okay? These are hyperbolic functions. Okay? That's one shape you'll notice on these. Okay? Another shape that you'll notice on these graphs are those involving a square root of x. Really, a square root or any type of rooted x is related to an exponential raise of a function. So let's have a look at that real quick. Let's use the keyboard for this. Let's do square root of x. Okay. Notice, and let's put these side by side. Notice you get the same signature shape, kinda, where it seems to approach something and then go on forever. But notice with the square root of x, it approaches 0 and doesn't want to go anywhere else. Hang on, let me open up the graph again. Sorry, y'all, I just realized I started talking again without showing the graph. So notice here we're starting at 0 and then we just go on forever. Okay, and we just shoot out of control really fast. So this square root of x shape is very similar to the ones we looked at before. They don't seem to want to go below 0. Let's look at the one we looked at before so we can put them side by side. Notice this? Look at this. Equals, let's just do 5 to the x, okay? Make sure you use this AB button for that. Okay, notice this same pattern. It doesn't want to seem to go below 0. Okay, it just has a hard, it struggles with going below 0. But notice the difference. In your hyperbolic function, remember that some number to the x power, that it gets really big and really small. Notice that the square root of x it just goes big, and it doesn't seem to want to do anything else. And it certainly doesn't want to go this way or anywhere down here. Okay, we'll talk about why later when we get into domain and range. But you can consider this. The square root of x means to take the square root of whatever's in there. Remember that you can't take the square root of a negative number because anything times itself won't be negative until you get into something called complex numbers or imaginary numbers, but we're not doing those today, okay? As far as all real numbers are concerned, you don't go below 0. So square root graphs will always stop at 0. That's the key takeaway. Square root graphs will stop at 0 and only get bigger from there. Hyperbolic graphs go below 0, but not on the y. They don't go down here, but they go below 0 on the x. Okay? Hyperbolic graphs will go below 0 on the x. Square root graphs will not go below 0, period. Nowhere, x or y. That's one way you can kind of separate this out in your mind. Okay? This is a square root graph. And remember, it cannot go below 0. Hyperbolic graphs, the y cannot go below 0. The x absolutely can. Okay? All right. Now, you don't necessarily have to remember those right now because we'll touch that again in domain and range, but I just want you to get familiar with recognizing the graphs. Just remember the square root is going to have this funny kind of rocket launcher, or not rocket launch, but this orbital shape almost, like where you're launching a missile off of Earth. And then your hyperbolic functions will make this sort of fun wide C shape, okay? Let's look at another type of graph. And y'all screenshot these as necessary. I think screenshots are going to be helpful for something like this. Just like lots of examples to just keep like in your phone to flip through the night before a test. Okay. All right, let's look at another example. Let's do the cube root of x. Now, some of you may be expecting the cube root of x to be just like this, but remember, cube roots are different than square roots. A square root says what times itself will give you that answer. And remember, because it's times itself, it will never be negative, because even if you take two negative numbers and multiply them times themselves, you'll always get a positive number. So it'll never be below 0. But cube roots are different. You can have the cube root of negative 125 and be just fine. Because remember, 3 negative numbers do give you a negative answer. So you should expect this graph to go below 0. All right? Let's have a look and see. Let's have a look and see what this graph looks like. So let me make sure y'all can still see the graph. I have to double check and make sure I'm not hiding the graph from you because I do that on accident. Sorry. All right, let's do f of x equals, and then when you need to do a power higher than square root on here, let's see what you need to do. I know there's another way to write it, but I'm trying not to give you a whole bunch of new concepts all at once, unless I have to. Okay, here you go. So you can use this button right here. This square root sign, which is really just a root sign, because square roots, to be technically right, square root should always have a 2 in it. I know it's assumed a 2 in there, but technically that's wrong. It's really just a root, and you have to put a 2 to denote that it's a square root. So this n with a root symbol lets you know that you get to determine which root. We can do 16th root, we can do 5th root, it doesn't matter. Let's do the cube root of x. Notice the shape. Very, very, very similar to the square root, except unlike the square root, it goes negative. And we just talked about why. Of course it's going to go negative. It's a cube root. It could go negative. Okay? How would you solve f of negative 1 for this graph then? Well, let's take a look. Put your mouse over the negative 1 on the x, and let's go down to where it touches. F of negative 1 for that graph is negative 1. Let's solve f of 2 for this square root graph here. Okay, let's solve f of 2 for there. So let's stick our mouse over here at f of 2, or really x equals 2, and go up to where it hits that square root graph. 1.414. Okay, and if you actually put in your calculator the square root of 2, you'll get 1.4141414. Like, it'll go on forever. Okay, let's compare that with the cube root. So let's find f of 8 for this. And some of you already know the cube root of 8, but let's do it. 8, so f of 8 for that function should be 2. Okay? This is how you read graphs to pull out the answers. Okay? Put in your formula first. Then when they ask you for f of whatever, you take your mouse, hover it over that x, and follow it till it hits the graph. Let's quickly find f of, I don't know, let's go with f of 27. Okay? So let's go all the way over here. And you can see now, while I'm not doing this on the iPad right now, I'm not about to graph 30 points. Okay? We're going to use Desmos. Okay? Cool. So f of 27, let's go all the way up. F of 27 is 3. Okay? So these really aren't so bad once you get comfortable using a graphing calculator. Okay? And I'm really happy to see that y'all get to use your graphing calculator on these. All right? This is really good. This is really good. Your teachers are not trying to beat you up. They are giving you some advanced material, but that's a wonderful standard. We can rise to the standard. We will not complain about the standard. Okay? Let's rise to it. All right. Now, let's move on to our next one. So let's zoom out. Let's get back centered. All right. And let's go ahead and clear these out so we can make room for some new types of functions, okay? These next ones here are called absolute value functions. So the bars for that, let's go into our functions. You're looking for the straight up and down shape, okay? Now, I don't see that in here, so we might have to actually look for the word ABS. That's another way these sometimes denote absolute values. So let's look for ABS. Maybe it does it like that. And if it doesn't do like that, I know how to do it on the keyboard. I was just trying to give you something simple. Okay, yeah. Oh, there it is. Oh, yay! Never mind. We're gonna pretend like I didn't just completely skim over it. Whee! So this is absolute value bars. Okay, let's put in the absolute value of x minus 10. Okay. Do not close it in parentheses. All right. For those of you wondering how to do it on the keyboard, it's right above your enter button. If you hold down shift and press that straight up and down bar, that'll give you absolute value buttons too. Look at this shape, this sort of signature V shape, okay? That's a little weird. When you see that V shape, that is called an absolute value function. You'll learn about these later on if you haven't already, but absolute values tell you to tell the literal absolute, as in, don't worry about it being negative, just tell us the actual number value of a function. That's why they're called absolute values, as in, find the value normally, then tell us what it is absolutely worth. So what that means is if someone asks you how much money you have, instead of telling them you have negative $10 because you're in debt $10, you would be like, it's $10 and I just happen to owe it. Now, I know that may have sounded strange because as it left my mouth, I'm like, that's not what I meant. So don't worry about it. Just absolute value. Absolute value can't have a negative value. Okay, it will always be above 0. Very similar to another graph we talked about. Remember? Let's have a look at it real quick. F of x equals what? See if you can remember it. Hopefully you said the square root of x, right? Never goes below 0. Unlike the square root of x, though, square root of x kind of dips off to one direction, and the absolute value of x zips off in both directions. See that? This graph right here, the absolute value graph, will look very similar to another graph, your x squared. It'll look similar, but notice the difference between the two. Absolute values always make a V shape, okay? And your x squared function will make this kind of curvy parabolic shape, or parabola is its official name. And that's because it's a type of exponential function. Exponential just means it gets out of control real fast. So x squared is going to shoot off into the sky real fast, and the absolute value of x is going to increase, but it's going to increase steady, slow and steady, okay? Tell me then, for this function, f of x equals the absolute value of x minus 10, tell me what f of 15 would be. See if you can eyeball it on my screen or do it on your own. What would f of 15 be for this function right here? What would f of 15 be? Okay, hopefully you can see f of 15 should be 5. What would f of 5 be for this function? Pause me now if you want to try it yourself. F of 5 should be 5. Okay? So both of these are 5. Okay? We'll explore why another time. All right? For this next one, tell me what f of negative 3 would be for the second function here. So f of x equals x squared. What would f of negative 3 be for this function? Take a minute, work it out. And these should be pretty easy, right? Once you can eyeball it, you can do it. F of negative 3. Pause me if you haven't already. So f of negative 3 should land right here at 9. And think about it. That makes perfect sense. Negative 3 squared is 9, because negative 3 times negative 3 is 9. What then would f of 5 be for this squared function? Okay, hopefully you scrolled up and you're like, man, that should be 25, because 5 times 5 is 25, and indeed it is. So these should feel okay once you get kind of used to seeing it and looking at problems differently. This shouldn't feel like anything too bad once you've learned how to read it. Let's have a look at another one. F of x equals negative square root of 5. Or sorry, not 5, x. All right? Notice this square root function went negative. But did it really? Only kinda. The square root itself is still not negative. It's only going negative because you're multiplying whatever the answer is by a negative sign, by a -1. So let's say you take the square root of, let's have a look at it. The square root of 4, which is right here, is 2, right? But since you said it's negative times whatever the answer is, it became -2. Okay? The square root of 4 is not -2, but if you take negative and multiply it by the square root of 4, you do get -2. And that's what's happening here. Okay? If that felt a little confusing, let me know tomorrow, or let me know sometime this week, and I'll show you the workaround on that, okay? But the big thing I want you to take away from this lesson tonight is how to see answers on a graph and how to put it in Desmos. So hopefully, if nothing else tonight, you can look at a worksheet, put in exactly what you see on the worksheet using these buttons down here, and I hope I've done a decent job showing you what buttons to press for what. Remember that square root button is here, absolute value button is here, that's that straight up and down, that when you need to take some root that's not a 2, you have to use this button here. And when you need to do exponents, they're here. I think I already covered that. And that you can, with that knowledge, take anything off your worksheets, stick it in Desmos, look at your graph, and then if they ask you, let me ask you right now about f of 15. What is f of 15 for this graph? See if you can eyeball it. Okay? Hopefully you can see. Pause me if you haven't now. Okay? f of 15, take your pointer right here at 15, come on down. It touches the graph right here at -3.873. So if you were asked on a test, as long as you had access to a graphing calculator, at random, for f of x equals negative the square root of x, what is f of 30? Okay, good luck figuring that out, just eyeballing. Or sorry, just working it out on paper. Although there are some techniques, I'll show you those later. But you can take your mouse, start at 30, and come on down. Ta-da! It should be -5.477. Okay? Put in exactly what you see on the worksheet. Let Desmos guide you. Let it graph it for you. Then take your mouse and follow for the things they're asking you for. Okay? If the negative of a square is not negative all the way, hold up, I just got a question here on Discord. If the negative of a square is not negative all the way, why does Desmos put it at negative? I'm not really sure what the question really is, but here, let me just put it to you like this. When you work this out, if you're talking about this one right here, when you work this out, look at it in pieces. This is saying negative, which when you see a negative sign by itself, it always means -1. This is saying -1 times the square root of x is your answer. So think about it. The thing underneath the square root is not going to be negative at all. It never is. But whatever you get out of the square root gets multiplied by -1. So all the answers for this are going to be negative because you're taking a -1 and multiplying it times your square root answers. And square root answers have to be positive. Okay? That's a half-truth, by the way. But we're going to go with it for now, all right? All right? Good. I'm glad that straightened it out for you. But don't hold on to that too tight because the square root of 4 is definitely not always 2. It is actually plus and minus 2, but we're not doing that today. Okay? Now, here's the graph. Just be familiar with the signature shape. When you see this starting at 0 and going off into infinity and beyond, that is some type of square root function. Okay? Whether it be up or down, just depends on the sign in front. If it's down, it's because you negated it. Remember, some of you who had me in 7th grade, I taught you that negative doesn't mean negative, that it means opposite. And now you can see graphically how that is true. The opposite of being up is being down. This wasn't just random. This is what negative actually means, okay? And remember that when you see that signature sort of double square root shape, that is some root of an odd number. So let's actually put the 5th root of x in here and watch. It will make a similar shape to the cube root of x. Look at that. Let's change this 5 into a 3. Look at that. Any odd number is going to produce that pattern. So Mike, does that mean that the fourth root is going to produce the same thing as the square root? Absolutely. Any even numbered root is going to produce that same signature starting at 0 and going into infinity shape. But notice as the root gets bigger, the graph gets flatter. Okay? Not going over reasons for that today. If you can find your way to it, great, but we're not doing that today. Okay? All even number roots will make that signature kind of going off into infinity and beyond shape. All odd number roots will give you this sort of boomerang zigzaggy shape. Okay? Got it? All right. Let's have a look here at the packet and just see if there's anything else we need to touch on for this part of graphing functions. Because at this point, I'm hoping you would feel confident with a graphing calculator putting in an equation and being able to look at that graph and pick out any answer you need. I'm also hoping that those of you who have this packet and you look down for where it says for 10 through 13, that you could almost actually look at the answer choices without a graphing calculator and hopefully be able to tell, based on what's happening with the x, what graph is it. Remember that I've already taught you that when you have x and there's no funky exponents and there's no funkiness happening to the x, that it's always a straight line. Whether it be x plus 10, doesn't matter. Whether it be 155x, doesn't matter. Well, whoa, that's a pretty tall graph. 15x, doesn't matter. It's still going to be a straight line. It's just a straight line. Okay? Let's put a 3x on this. Just a straight line. But the minute you stick an exponent on it, it's over. And if that exponent happens to be an even number, it's going to always make this sort of U curvy shape. Any even number on an exponent is going to make this U curvy shape. Okay? Any odd number on an exponent is going to make this kind of sort of zigzag shape. Okay? Any root that is an even number is going to make the boomerang shape, or not boomerang, sorry, the kind of going off into infinity and beyond shape. Remember that? Any odd numbered root is going to make this boomerang sort of shape. Now, let's have a look at something real quick. Notice the cube root of x gives us, oh, sorry, I just gave you the same thing. Hang on. Notice the cube root of x is really just the cube of x turned on its side. Take a look. If you take, here, let me X this out for you. If you take this purple shape here and turn it on its side and mirror it, you end up with, hang on, let me put this in for you. You end up with the zigzag shape that is the cube root of x. Oh, and sorry, this right here is just another way to write the cube root of x. Hang on. Let me put it in here. Let's sorry. I was just, you know, there's more than one. Here we go. All right. There you go. Okay? Notice that? Pretty neat. So when you see that signature boomerang shape, it's some odd numbered exponential thing going. If it's going up and down, it's an odd number exponent. If it's on its side, it's some odd numbered root. Okay? Odd numbered root. Compare that with if it's making that curvy shape. Okay? All right, we're going to make that U shape. That is an even numbered exponential function. And that if it is a even numbered root, that we're going to make that sort of off into infinity and beyond shape, which I'll be kind of, you know, gentle with, or I'll be more kind here to the even numbered roots, if you give a negative version of the square root of x, you actually make a sideways parabola. Okay, here, let me take this out so it doesn't confuse you. Oh, sorry, I think I might have just made it bigger than you can see. Okay, can y'all still see the graphs? Okay, you can still see the graphs. Look at this. Square root of x. Notice that makes a sideways parabola. Okay, so really the same thing is happening when it comes down to roots and their exponential counterparts. You're taking what they do up and down and just flipping them on their sides. It just happens to be that you have to take an extra step with even numbered roots because they're not going to be below 0 unless you make the answer negative, because it cannot be inherently negative itself in a real number system. There are things called imaginary numbers. When we get into complex numbers, we will talk about that, but I think that is way off later in the year. I think y'all are going to touch on that in 8th grade, though, I think. So we'll talk more about that later. But let's have a quick look at an even numbered exponential function, and then we will get ready to wrap up for tonight. Okay, got it? Okay, and then remember, if you see some number to the xth power, that you should see this signature getting really big really fast and really small really fast, because think about what it means. 5 to the x means you're taking 5 and multiplying it times itself that many times. If you just do it once, it's not a big deal. You end up with 5. If you do it once, you like here, look. So like 5 to the 1, right? That'll give you 5. If you do it twice, you're already at 25. Well, that's bananas. If you do it 3 times, you're at 125. Okay? And if you do it 4 times, you're at 700. Or sorry, not 700, 625. Look at this. You got to go all the way up to 625 just in going from 1 to 4. That's why when you get to these exponential functions, they go out of control so fast. Now, we haven't talked about what a negative exponent means, but it basically means make it into a fraction. So 5 to the negative 1 is 1/5. 5 to the negative 2 is 1/25. 5 to the negative 3 is 1 over 125, because it's 1 over 5 to the third. So these numbers get incredibly small really fast. The same as how positive numbers on an exponential function make it really big really fast. Negative numbers make it really small really fast. And that's how you're going to sniff out the difference between this and this. Oh, sorry. Okay. Is when you have a number to the xth, it's going to go in both positive and negative directions, but it cannot go below 0. Because there's no number that you can multiply 5 times itself and make 5 go below 0. You can add stuff to 5 to make it go below 0. You can subtract stuff to make it go below 0. Heck, you could even multiply negative numbers times 5 to make it go below 0. But you cannot multiply 5 times itself enough times to make it go below 0. So these exponential functions, unless they're odd numbered, are not going to go below 0. Okay? Okay? Still doesn't go below 0. Got it? The only way to make this thing go below 0 is to stick a negative number in front of it. Now to go. Okay? Unless, remember the exception I told you, you have something to an odd numbered exponent. And that's because odd number exponents do not care. Like the minute you hit that third one, it can be negative. Negative 2 times negative 2 times negative 2 is going to give you a negative answer. Because every odd number out on a negative set will give you a negative answer. Okay? Alrighty, that should be really thorough. That was a lot longer than I intended, but that should cover everything on this graphing part and should give you a lot of reference. Use your graphing calculator so you feel familiar with this. I'm not going to show you how to do these by hand so much today. I don't think we're going to spend a lot of time on that as we need to move on to other sections so we can stay ahead of the actual classrooms, okay? Because when people come to see you, you got to know how to help them. So we have to stay ahead. But hopefully that's helpful. If you have questions on anything else, let me know. And I will get y'all the video on inverse functions tomorrow at the school. Okay, have a